Here we go. We're going to talk about rotations again and dilations. And you should already have the rules for rotations, but we'll give them again as well. Okay, because this week we looked at reflections and translations. And so next week we'll look at rotations and dilations. So go ahead and write this down first. Rotations and dilations. We're going to do page 33, number 5, which is a math practice rotations question. We're going to look at the module 1 review so that you can create a one-pager, which is like one page of review material so that when it comes time to studying, you have everything right there in front of you. And so you should have a section for each transformation, the rules for each one, an example of each, any notes that you need to remember based on what you've practiced and what you got right, what you got wrong, and then real world applications for each transformation so you understand why they're useful. And then we're going to look at dilations for the second part of the video and all about how you can perform dilations. Okay, so let's start off with number 5 on page 33. Model with mathematics. Elias graphed the movement of 1/4 turn of a ceiling fan. Continue the rotation and draw the fan blade in the third and second quadrants after 2 more rotations of 90 degrees each. Describe the rotation of the fan blade from F to F prime. So I'm going to take, and I want you also to copy this down into your notes. So I'm going to pause the video and do that. And then we're going to rotate to make this same, this is like a fan blade. We're going to make the rotations to make the fan blades here and here. All right, let me pause and put that in the. All right, here we go. So I just had to copy down a lot. So I made the graph, right? I went to 7 for each one of the axes, 7 and -7. And then I labeled my rectangle A, B, C, and D. I also put the coordinates right here. So A is at 2, 1. You can see that. B is at 6, 5. C is at 5, 6. And D is at 1, 2. Okay, so even if it's not exactly accurate here on my sketch, you can see the pre-image. So P stands for pre-image, right? So now we're going to rotate each one of these coordinates by 90 degrees, 180, and 270. And we already have the 270-degree rotation right here on F prime. This is 270 degrees, or you could say -90 degrees. It's the same rotation. So now we're going to rotate. We're going to get the 90-degree rotation, put it right here. And we're going to get the 180-degree rotation and put that in the third quadrant. Okay, so how we're going to do that, we are going to go ahead and just write down our coordinates for each one. So rotating by 90 degrees means XY changes to -YX. So whatever my Y coordinates are, they become the negative version, and then the X goes as the second number. So all my Y's, I'm going to just do that first. I'm just going to rotate them all at the same time. So all the Y's get to be the first number in my rotation of 90, and they all have to be negative. So 1, 5, 6, and 2 are my Y coordinates, right? Excuse me. So in my rotation of 90, I'm going to have -1, -5, -6, and -2. Those will now be the first numbers in my 90-degree rotation. And then 2, 6, 5, and 1 Those are my y coordinates. So all the x's are the y's, and all the y's, the opposite of the y's, are my new x's. Now I can graph that, and what we'll see is the rectangle pointed up this way, and it'll look like a 90-degree rotation of f. So -1, 2, that's going to be my A prime. -5, 6, going to be B prime. -6, 5 is going to be C prime. And -2, 1 is going to be D prime. So again, just a sketch, so it's not exact, but you can see it's pretty good. So that is a rotate. That's what it looks like when you turn this figure. And so we'll just call that F double prime since they already use prime right there. Okay, and if I had made my intervals a little bit more evenly spaced and maybe used a grid, it would look exactly the same. But this is good enough to get an idea. All right, now for a rotation of 180 degrees, you don't have to switch anything around in terms of the X and Y switching. You just have to change the sign on the X and the Y. So I'm going to write, instead of 2, 1, I'm going to write -2, -1. Everything just changes to the opposite. -5, -6, and 1, 2 changes to -1, -2. Not too bad. So now when I graph these four, it'll create a rectangle down here, which is 180 degrees or halfway around the circle. -2, -1 is right here. -6, -5, -6, -5, -5, -6, over -5, down -6, and -1, -2. And we end up with a rectangle like that. So we'll just call that F triple prime. All right, so now we've created our fan blade, and then let's just finish our table so that you know how to do a rotation of 270 degrees. Okay, so 2, 1, and when you're rotating 270, again, all the y coordinates become your x coordinates in the 270 rotation. And the x coordinates become your y coordinates, but actually the opposite of the x coordinates. So again, I'm going to make my y coordinates 1, 5, 6, and 2. So I'll just put those first. 1, 5, 6, and 2. And my x coordinates are 2, 6, 5, and 1. But I'm going to write -2, -6, -5, and -1. And you can see 1, -2, we have that on here. 5, -6, 5, -6. We have that right here. 6, -5, that's right here. And 2, -1, we have that. Okay, so that is the 270 rotation. Just one more thing to say about these. So these are all counterclockwise rotations. All of these, you just gotta write counterclockwise. So counterclockwise is positive. You get? Okay, see. And so clockwise is negative. So let's just write down a little chart here. Clockwise is the negative version of our rotation. So we can, so if we have 90 degrees clockwise is equal to -27, or is equal to positive 270 degrees counterclockwise. So you see how I said 270 degrees is equal to negative 90 degrees. And so 90 degrees clockwise is the same as negative 90 degrees. So 90 degrees clockwise, also known as negative 90 degrees counterclockwise. So it's a little confusing, I think. But that's equal to 270 degrees counterclockwise. 180 degrees is easy because that's halfway around. So it doesn't matter what you say there, clockwise or counterclockwise, it's the same. That's nice. But 270 degrees counterclockwise is equal to, no, that's gonna mess you up. All right, so 270 degrees clockwise is equal to 90, 270 degrees clockwise would be equal to 90 degrees counterclockwise. See, it's even confusing to me. So 270 degrees clockwise, also known as negative 270 degrees counterclockwise, same thing, is equal to 90 degrees counterclockwise. So you're going to have to practice that a little bit, but I like to think about all rotations counterclockwise, going this way. And then if I have to do any clockwise stuff, I just translate it into my head. Okay, wait, 90 degrees clockwise. All right, what are you really saying there? Oh, you just want me to do 270 counterclockwise. Okay, so if I see something like this, then I just remember these rules, which are already here. That's how I do that. Okay, so it's a little bit of rotation practice. And so every time you look at a fan blade, you should say, wow, there it is again. Rotations. All right, so now we got section 1-5, but we're gonna kind of move past that. That's just talking about congruent figures, which we have talked about. And so you see module 1 review on page 45. We have our different vocabulary. So, image, pre-image, reflection, rotation, translation. We have talked about all of those. And so what I just want to say about this review is that you would look at it and you would use these questions to create a one-pager. Okay, so let's talk about what that is again. So one-pager is going to be literally one page that has the rules for each transformation, examples of each, notes to self, and real-world applications. Okay? So you're going to create a page that says transformations review. Okay, and I'm not going to do this all right now. I want you to make it. And I want you to, you're going to write small. You're going to try to fit everything onto one sheet. And we might even let you use this one sheet on your assessment so that you have all the rules and you don't actually have to memorize all the rules, for the first time around. Okay, so try to make that, and we can work on it in class, but try to bring this to class with all 4 of these things. But right now, we are going to move on to dilations. Yeah. Dilations. We're going to do the step it out problem. This is a good one from section 2-1. Here we are. All right, step it out. So here we have a triangle, and we're going to dilate this triangle, which means change its size by a scale factor of 2, using a center of dilation at 0, 0. And then we're going to also shrink it by a scale factor of 1/3. That's what we're going to do to end the video. But before we do that, we're going to need to write down some vocabulary. what a dilation is, the scale factor, and center. So let me pause the video and put these things in the notes so that you have them too. Woo! Okay, that was a lot of writing. So a dilation, a transformation that produces a proportional image of a figure. Let's just write a proportion. Proportion is a fraction equal to a fraction, or a ratio equal to a ratio. That's what a proportion is. Okay, a scale factor, the ratio or a fraction of any corresponding sides of a pre-image and an image in a dilation. So I like to think of the scale factor as the image over the pre-image. So if I ask you what's the scale factor is, find a side in the image and the corresponding side in the pre-image and make it into a fraction. That's all you got to do. The center of dilation, we're going to look at that in just a minute. It's the point of intersection of the lines through corresponding vertices of a dilation. It's actually really beautiful, and you'll see it in just a second. So go ahead and make a nice little coordinate grid up to 20 or at least 18. Take your time, make it nice. Maybe we can even get some graph paper, but yeah, okay. And then we're going to graph triangle D, F, and E. So there are the points of D, F, and E. So yeah, pause the video and make what I did here. And now the first thing we're going to do is we're going to enlarge it by a scale factor of 2. Okay? Real simple. All you got to do is multiply by 2. So 3, 6 becomes 6, 12. 3 times 2 is 6. 6 times 2 is 12. 6, 6 becomes 12, 12. And 9, 3 becomes, what's 9 times 2? 18. 3 times 2 is 6. Okay, so D prime, F prime, E prime under the size change of 2 becomes this. Okay, so let's graph it, and then we're going to see this figure twice as big. So 6, 12 is going to be right about here. And that is our D prime. 12, 12 is going to be right about here, and that's our F prime. And E prime 18, 6 is going to be right about here. E prime. So now when I can connect it, and I would advise using a ruler, even though I'm not. I'm trying to be real careful, but it can be difficult. Okay, so you can kind of see it's a similar figure, but it's just bigger. And let's look at that center of dilation. So what that is talking about is I can draw a point between D and D prime and keep it going. And I can draw a point between E and E prime and keep it going. And I can draw a point between F and F prime and keep that line going. And they all intersect right here. That's called the center of dilation. Pretty neat, huh? So I was cheating a little bit because I knew the center was 0, 0. So, you can see my line for between the E's kind of is like a wiggly thing there. But in any case, that is what should be true about the center if it's not a sketch. Now, and then this size change also should go through the center as well. It should be on these 3 lines. All your dilations will be on these lines. So let's go ahead. This one is a stretch. Anytime we dilate bigger than 1, that's a stretch. Let's just write bigger than 1. And whenever we dilate between 0 and 1. If S is between 0 and 1, that is called a shrink. All right, so yeah, I should say, yeah, so okay, so let's multiply 3/6 by 1/3, which is the same as dividing by 3. 1/3 is equal to dividing by 3. So 3 divided by 3 is 1. 6 divided by 3 is 2. Okay, these divided by 3 would be 2, 2. And 9 divided by 3 is 3. 3 divided by 3 is 1. All right. Or I could say times 1/3, you know. Okay, so 1, 2 is right there. And so D double prime, that's right there. F double prime is at 2, 2. Okay, and E double prime is at 3, 1. So we can see all three are similar figures, right? And they all go across or through those 3 lines to the center of dilation. So it's a pretty beautiful thing, I think. Okay, so the nice thing about dilations is all we had to do was take the pre-image and multiply it by the scale factor. That's all I did to get these coordinates, and then you get the image. Okay, so this is one formula you need to know. A second formula, which is just another version of this formula, is the scale factor. As I said previously, is the image over the pre-image. You definitely want to know that. So just to show you, if I needed to get the scale factor and I had 2 points, I could take 12 and divide it by 6. 12 divided by 6 is 2, and the scale factor is 2. I could take 6 divided by 3. You could take any pair of y's that match, corresponding, any pairs of x's, divide them, and get your scale factor. It's a very easy thing to figure out. All right, guys. That's it. That's all we got. Hopefully this is less than 37 minutes. Have a great time dilating your figures and rotating them.